Okay, this was too fast forward. So let's start with the control panel of your webinar tool. You should see this panel on the right upper corner of your screen. Let's start with the text field below. This is for posting questions, for written questions. I would strongly recommend you to do your questions in written form because it is hard to coordinate oral questions, and it is also often hard to understand the oral questions because audio quality is sometimes poor and sometimes we have feedback. So if there are any questions, please post them in this text field. They will arrive at my screen and I will deal with them. I will forward them to the lecturer and they will get an answer soon. By this error, you can minimize the panel and have a full view of the presentation. This is the icon for the full screen. The icon with the hand is for raising the hand, so you can draw the attention to you by clicking this button. I will then get back to you via the chat. This is the icon for the microphone. It can be used to also unmute your micro, but as I already said, it is a bit hard to coordinate audio interactions. We have a lot of attendees today, so please stick to the written form of interaction and I will keep your microphones muted. They're all muted and the session will be recorded. So if you want to get back to this lecture or want to recommend it to your fellow students, you can then suggest the Foodstar website. I will introduce it to you later. Now some information about the European Food Studies and Training Alliance. It's an Erasmus Plus Knowledge Alliance project and started in January 2015. It's coordinated from the University of Natural Resources in Vienna. The coordinator is Gerhard Schleining. What is the vision of Foodstar? We see universities having knowledge from academic research. We see food industry having knowledge from the daily practice. The focus in universities is on research and on publication of results. The focus in the industry is on practical applications, on practical solutions, also on the protection of intellectual property, and time constraints play a major role. So there is a gap in these two approaches that Foodstar wants to close. By bringing together universities and food industry, we try to combine these different knowledge fields and enhance the interactions and exchange. The long-term partnership shall be established on a European level and the services shall be offered on a low threshold. The consortium is spread all over Europe. 7 universities are involved, 3 food companies, and 11 multiplier and training providers, such as LVA. Among the universities from the consortium, there is the BOKU, University of Natural Resources, then there's AgroParisTech, IPC in Portugal, UCP in Portugal, the University of Hohenheim in Germany, University of Leeds in the UK, and the University of Teramo in Italy. Among the food companies involved are Frulact and GB Foods in Portugal and Spain. A cooperative partner is Nestlé. Multipliers and training providers are also involved in the consortium. LVA is one of them, but also Actia, Federalimentare, ANIA, FIAP, SEFT, FIPA. They are all industry-related associations. Teachers, industry, and students are represented by IFA, EFOST, SPES, and EROICA. The food centers that are established during the project are physical hubs. So the food network is not only a virtual one, but we do establish physical hubs. LVA is one of it, cooperating with the University of Natural Resources. And this shall also enhance the collaborations between industry and academia. Innovation is a key factor for the food sector in Europe. But what does innovation mean? It is the access to expertise of up-to-date and new technologies that is needed to innovate. Multidisciplinarity is also required. And regional cooperations with clusters and centers of excellence shall be streamlined and brought together by the Foodster support. We support accessibility to experts and partners on EU level by bringing together these forms of regional cooperations. The members of the Foodster centers are project partners and associated project partners from the consortium, but also external partners from food industry, training providers, and other universities. This network builds up to the European Foodster Center members network. It is free and it is still accessible. You can apply via the project website www.food-star.eu. So this brings me to the presentation of today's speaker. It is Professor Cristina Silva. She is from the Portuguese Catholic University and is a professor there in the College of Biotechnology. She is, I think, from the origin, so she's a chemical engineer, but maybe you correct me if I'm wrong. Right. You did a lot of research on quality and safety of processed food, and the emphasis is on mathematical modeling and optimization. You're editor-in-chief of the International Journal of Food Studies and past president of the ISEKI-Food Association. Today's topic of the lecture is the integrative predictive modeling for food safety and quality for tools and applications. And we are looking forward to your presentation, Cristina. Are you ready?
Yes, yes.
So please give me a second to hand over the screen to you. Yes, great.
Is it working okay? Yeah.
Yes, it works fine. We can see your presentation and looking forward to your lecture. Please start, Cristina.
Good afternoon to all participants. It's a pleasure to be here making my first webinar. So the topic of my presentation today is integrative predictive modeling for food safety and quality and tools and applications. I am going to make a general introduction because I assume that maybe some participants are relatively new in this topic. Then I will make a presentation of different tools that exist for food modeling, and I will present some case studies, those ones where we have been working, and at the end some challenges of the field. If then some people have more deep interest on the topics, they can contact me, and I'm open to answer and help. So let's start with modeling food quality and safety. So as I think everybody knows, food safety is one of the food pillars, and it's always the most important criterion for food processes. Food safety has to be guaranteed. I'm not going to go into much detail on here. Food quality, of course, is also important, and but until now, the main focus on modeling had been more on food safety and more recently also food quality. Food security, ensuring good, safe and of good quality food for everybody is also an important area of the food field and should be also considered for modeling and optimization. And of course, the environmental impact. So, food has first to be safe, but then it has to be nutritious, healthy, tasty, fresh, natural, convenient, ready to eat, affordable, environmentally friendly. How computer simulation can help on this? So computer simulation requires knowledge on how the microorganisms or enzymes degrade, how quality also is destroyed, and this is there is enormous amount of work on databases, especially for food safety aspects on kinetics. And then transport phenomena, heat transfer, mass transfer, fluid mechanics. These are the three transport phenomena involved in unity operations. There is also in the food engineering and chemical engineering experts working a lot on transport phenomena. Then when it's combined, both kinetics and transport phenomena, not so much is yet available. And of course, to get these models, we need data. So, to mathematically describe the real system, we need equations. And I'm not going in too much detail here because don't know exactly, this is the basics. If I would go to explain the equations for these relationships, like transport phenomena, kinetics of quality changes and of safety, this would take another presentation. So these equations can or maybe can describe as much as possible the real system, but many times they are complex. So when we use the equations, we have mechanistic models. However, it's rather difficult to get data for these models, and many times we have the empirical models that are simple and play easier to be used in practice. So mechanistics or empirical sometimes is difficult to distinguish between both of them. To model the processes, then we have different mathematical methodologies like finite difference, finite elements, finite volumes. We have different mathematical approaches like computer fluid mechanics softwares. So these are quite complex softwares, but are being used not so often, combining transport phenomena with kinetics. There is also the response surface optimization that is also very useful to optimize the process conditions. So the role of modeling food can be to design a process, design a product, optimize the process and product, can be used to predict safety and quality along storage and distribution, or even optimize the conditions of storage and distribution. So modeling can be used along the whole supply chain, since the idea, primary production till the consumption. In our area, I usually work much more on industrial production and storage and distribution. So computer models are being used for characterizing food quality, for process design and optimization, real-time process monitoring and control, food storage, and performance management. At the moment, a cost action is running. It's there in my slide and can be quite interesting if someone wants to join this cost action. So this is my introduction, and then I move to food modeling tools. So first, speaking about predictive microbiology, which is a tool to predict the safety of the product. So this predictive microbiology is the description of the microbial responses to environmental stressing factors like temperature, pH, and water activity. Usually the most common is with the temperature, but pH and water activity is also important, and several works are running on this. So predictive microbiology basically include the primary model, that is the description of the log number of microorganisms as a function of time for constant conditions, and determine the kinetics. Then study the effect of different stressing conditions like pH, temperature, water activity, and determine these parameters. And then there are the tertiary models that are the integration of the previous models. And there is software available to predict, for some cases, the safety of a given food product or group of food products. Usually, this software existing in the databases, they consider isothermal conditions. I mean, for example, for temperature, they consider that the temperature is constant a long time. And in reality, the conditions are not isothermal. And so this is also a challenge. This is also a challenge for the people working in this field to provide software that can predict adequately the safety of the products under non-isothermal. So these tools are able to design processing conditions, like, for example, pasteurization conditions, and also shelf life studies. And they are available for industry, and for example, the software's Baseline, Combase, and I have here a reference that makes a compilation of the most important tools available on the web. I move now to predictive quality. So I would this term predictive quality is not yet very common, but is something similar to the safety. Is the use of mathematical models for the description of quality responses to environmental factors. Why quality changes? If we want to optimize the process, we can, of course, optimize in terms of energy consumption, but also in terms of maximizing the quality. Usually, the quality changes are based, kinetic studies are based on single response studies and under static conditions. And again, many times in practice, the conditions are not static, and several responses are involved. Anyway, for single responses and about empirical models, there is lots of information for different products, different quality parameters like vitamins, color, texture, and usually they use quite simple kinetics like zero order, first order, or fractional kinetics order, and they use the Arrhenius behavior as an empirical model to describe the temperature. But for quality changes, no databases are yet available. Multi-response model. So when several compounds are involved in a reaction, I give here the example of sucrose degradation in different compounds, and it's possible to develop mechanistic models that can predict the concentration of the different compounds along a process. Here are some examples of our results over time. This was developed some years ago for a project related with sugar degradation because a lot of Portuguese traditional sweets involve the degradation of sucrose, and so this was the reason why we did this study. But this approach may well be used for other fields. Another very classical example is the canning of foods. Here I show an example of canning of a product in just changing the size of the can. So we need to have knowledge on the heat transfer phenomenon inside the cans, and at the same time the kinetics of change. So we need to have the temperature story distribution and at the same time the kinetics. And we can see on the right side very well the difference between two products that have been processing under different conditions. So it's very important to combine this knowledge. For safety, there is a lot of work on predicting the safety of the canned foods, but for quality also not so much. So quality change kinetics under isothermal conditions can be described by relatively simple equations, but if we do non-isothermal condition, we need to have integration, and this for quality changes is really a need. And also the use of reverse engineering can be also an excellent tool to get the kinetics from the final product result. So I consider the integrative predictive modeling the combination of mathematical models for safety and quality responses, and considering dual food chain. And in fact, I also, sorry to mention again this cost action, because it's really an innovative topic. Once last year this cost action was approved, and a lot of institutions and all the European countries are involved, and you can get more information on this site. And in fact, is the use of modeling and optimization methods for the food sector. So the modeling, the link between food processing and food structure, modeling the eco-design of food process and software tools for the food industry. Under this project, compilation of available softwares is being done and soon will be available. So now I move to some case studies to give, because I can imagine that my presentation can be a bit not so clear, and giving some examples can better demonstrate the usefulness of these tools. So the first example on post-harvest treatment, we did some years ago in some studies on water treatment for tomato to help to extend the shelf life. So we did some water treatments with 40 degrees during 30 minutes, and then cooling, and after that drying, and then storage. And this was compared with industrial decontamination with hypochlorite. We did measure several parameters, but one of the most important was the firmness, and here you can see the results of experimental and predicted firmness a long time. And we were able, the same, we did similar for color. And we were able to model using simple and empirical equations the color change and the firmness a long time. Of course, I cannot go explain this work very much in detail, but I have the reference. But through this modeling, we were able to demonstrate that any treatment can prolong the shelf life of the tomato at least twice if stored at 10 degrees Celsius, which is the normal storage refrigerated temperature. Another example is on non-thermal technologies. So we studied the inactivation of a spore that is a Bacillus acidoterrestris that is resistant, it can grow under acid conditions, and we did the study in apple juice. We use 3 different techniques, UVC radiation, ultrasounds, and ozone. And we did study the kinetics of inactivation of these spores under different conditions. And these models can help to define the best conditions for one of these treatments, ultrasounds, UV or ozone, or combined treatments. Here the same, similar results, and also, for example, for UV, the impact of the effect of the intensity of the treatment on the D value, which is related to the velocity of inactivation. We also did some work on thermal inactivation of listeria in media culture and in foods. And here it's just where you see media and parsley, you can see that the behavior of the microorganisms is different when subjected to the same temperature conditions, is different when it's in media or when it's inoculated in a real product. So the product has an effect. So when tools that are available and web predict some inactivation, you may get different results when you have your own product with a different, for example, water activity or some protection that the microorganism finds in the product. And so the prediction is an estimation, but it may not be exactly to the values that are predicted on the web. So also they use here the prediction of quality along storage and distribution of frozen vegetables. So on the right you have the temperature that raising. So this is because a long time during the distribution you may have different temperatures, because it's not possible to maintain always at -20 degrees the product. And the simulation and also the experimental results of the quality, in this case the texture, along the time. So this is combining the transfer with kinetics. Another example that I really appreciate is the solar drying of grapes. So solar drying is the drying using solar energy, but in a cabinet, like it is shown on the right picture. And then during this drying inside the dryer, the temperature and the humidity is changing along the time, because conditions change due to day and night, and also because of different weather conditions. And through simulation, we were able to predict the water content of grapes during drying. So, what are the challenges in this field? Is the first one is the development of these models considering the food chain, because the final quality of a product is depending on all steps of the chain, of the food chain. Also, to have correct kinetic data and kinetic studies using dynamic conditions, because as I mentioned, under dynamic conditions, the behavior of microorganisms especially can be very different than when static conditions are used. Also, the use of reverse engineering, so using the result to predict the behavior, because mechanistic models are not easy to develop. So also multi-response models, mechanistic models is very important. And the development also of a so-called predictive quality and an open access database of kinetic studies for quality that could be usable to predict the quality of the products. So, and with this, I think I am on time. I finish my presentation and I'm open to questions.
Thank you, Christina. Thank you very much. So it must have been a very comprehensive presentation, because I have no questions from the audience till now. I'm sure this is also quite, let's say, a heavy topic, a bit hard to grasp all of it, maybe just in the 1 second that you have to get it. And well, I'm sure it's not so easy.
It's not so easy, and if what I decide to present it in this way, and later, if the organizers wish, I can develop, for example, for the solar drying or another aspect, but to give a general.
So in the meantime, I have questions.
Okay.
So Marcel Zwittering is asking, in the parsley example, or parsley, I think, example, it seemed that Listeria was already inactivated between 30 and 40 degrees Celsius. Is parsley so antimicrobial, or did I see this wrong?
Oh, you see, because it's because this is I have to open my presentation because I have it printed but it's small, and I want to understand the question. Okay.
is the listeria and the parsley.
The time is minutes, yeah. But
Do you show it on the screen? Then I have to give you back the screen. One
yeah,
moment, please.
better is better. I'm going to I'm just going to switch off my camera. Okay. Can you do it now?
We don't see your presentation, but your camera is switched off.
But you have to invite me again because I said not yet.
Ah, okay.
Because I wanted to remove my camera, and then is it possible to invite me again, or I have to minimize?
Yes, I'm just trying, but I lost you on the list.
Oh.
So why?
Okay.
I don't know. But you're already showing your screen.
Okay, so but here what is represented on the axis is log n over n0, so is a dimensional amount of microorganisms. I don't know if I answered. So you mentioned that it was already 40, I don't know. So this means here we were still able to count the microorganisms. So this is because we model the dimensional quantity.
Okay. There's another question. It is from Athanasios Maras. Why is there a different section for food safety and food security? So it's the difference between food safety and food security that needs to be explained, I think.
Yeah, food security is not safety. Food security, I don't know, because also for me, the first time I learned about it, security, somehow the word is similar to safety, and we immediately, my brain takes me to safety because of my language, Portuguese language, but security means ensuring good quality the good quality and good amount food for all the people. And this is a mission of
It's
food.
about quality of food, that it does not harm your health. And
No,
food security is about security of resourcing, of sourcing.
Yeah, security to ensure, first to ensure food for everybody. And of course, the food has to have quality and safety.
Mm-hmm.
Yeah. So maybe I think is Athanasius. I think if you look on the Google, probably even a better definition. But the security is linked also with sustainability, is to ensure enough food for everybody.
Okay, Athanasius already says thank you for your answer.
Thank
And
you.
there's another question from Janet Bacalars. And it is about, first, thank you very much for your presentation. And the question is, do you think such models are also realistic for conditions on an agricultural field?
Yes, I see. It's not my area, Janet, but in this cost action, there is a lot of people in this field. Yeah, and but for sure, yeah, different tools, but yes, if you wish, maybe I can provide. You have my email, and I can maybe put you in contact with this cost action, and if there is people that can better explain what is available. Yeah.
Oh, wonderful. Yes, this is also a request from, or an offer from me to all the attendees. You can refer to us via email afterwards too. The emails will be collected by the coordinator and can be forwarded to the lecturer or to the coordination team, depending on the topic. So feel free to contact us via the internet site, via email. You have our contact details also in the email of today's webinar, of the webinar invitation. So great. Thank you, Christina. This was it. The questions are answered from the audience. So I may say thank you to all the attendees. Thank you, Christina, for your lecture. It was really a sophisticated topic and not so easy to grasp, but I think you did a good job today explaining the predictive modeling. So I may just show you the website of the Foodstar project now, and in this button, Events, you find the webinars that have been recorded so far. You can go back also to our 2 days lecture. We will upload the recording and the presentation later on, and all the webinars that have been done in the frame of the European Foodstar project are collected here and can be listened to, and the material be looked up at this website. So I wish everybody a good afternoon. Thank you very much for attending and have a nice time. Bye.
Bye, thank you.
Bye, Christina. Thank you very much.